Good day from OG Benchmarks. In this video, we'll look at the top-end Nehalem CPUs, which are marketed differently on paper, but seem to have the same performance stats. The Nehalem microarchitecture is capped by a number of 4-core, 8-thread CPUs. In the performance desktop category, there are 3 i7 CPUs, the i7-860, the 870, and 880. In the uniprocessor server category, there are 3 Xeons, the X3460, X3470, and X3480. These are the top-of-the-line Nehalem processors. So all these have 4 cores and 8 threads. How about frequency? Well, the i7-860 has the same frequency, 2.8 gigahertz, as the Xeon 3460, 2.8 gigahertz. The same goes for the 870 X3470 pair. Same goes for the 880 X3480 pair. It seems that this 60, 70, 80 trend in the names was not a coincidence. It's like we have 3 sets of twins in this group of CPUs. How about other specs? The L2 cache is the same at 8 megabytes across all the CPUs. The TDP is the same at 95 watts. Good night. Are any stats in these CPUs, are any of them different? No. Well, almost no. In looking at the Intel CPU archives, it seems that the 2 differences between these CPUs are, number 1, the i7s can handle 16 gigabytes of RAM, while the Xeons can take up to 32 gigabytes. And number 2, the Xeon support ECC RAM. That's not so surprising given the intended use of the Xeons is in servers. That's it. For most purposes, these 2 groups of CPUs should be identical. Let's test them in Cinebench R23 and see how they stack up. Here is my obligatory test bench slide. I'm going to use the various CPUs mentioned on the previous slide. My LGA 1156 motherboard is an Intel with the H55 chipset. The stock Intel cooler won't cut it, so I'm using a Cooler Master Hyper 212 Black Edition. I have 8 gigabytes of RAM, power supply, a G2 240 GPU for its handy HDMI video out, and an SSD with Cinebench R23 and some other software to monitor things like CPU power, speeds, and temperatures. On to the benchmarks. What's my plan? I want to benchmark all 6 CPUs. I'll run each benchmark 3 times to get a sense of consistency. So that's 6 CPUs, 3 times each for the single core and 3 times each for the multi-core, for a grand total of 36 benchmark runs. Once we're done, we'll look at all the results. Let's start with the i7-860. I got the i7-860 and ran the single core benchmarks, super consistent. While it was still in the socket, I ran the multi-core benchmarks, again very consistent. I then switched to the X3460. No surprises here. The scores for the X3460 were also very consistent and essentially identical to the i7-860. Great. Next CPUs, please. Here are the results for the i7-870 and X3470. These data tell pretty much the same story. The multi-core scores are a little bit more varied, but the numbers are still very similar. These 2 chips are pretty much the same CPU. Okay, moving forward. Finally, the i7 3480 and 3480 are much more the same. Maybe there's yet a bit more variation, namely in the multi-core, but not enough to tell a difference between these two CPUs. Let's visualize our data and see if we can learn anything new. Here is a bar chart for the single core benchmarks. We can see the pairs, the 260s, the 270s, and 280s. You might say that each of these pairs is not perfectly level. So maybe these aren't so similar. I'd agree that they are not identical, but the differences in these bars is accentuated by the shrunken vertical scale. If we look at this same bar chart with a full vertical axis, we can see that the pairs of values are extremely close. Always watch the scale of the axes. Here are the multi-core scores. Again, each pair is different, yet still pretty close in the big picture considering the vertical scale. Okay, I think it's fairly clear that the scores are really similar. I want to compare them one last way. Here is a scatter plot with 6 points. These are XY pairs. Let's think about one pair of CPUs, the i7-860 and the Xeon X3460. If we put the i7-860 score on the x-axis and match it on the y-axis with the X3460 score, then we can make a data point. In the lower left are all the single score pairs. In the upper right are all the multi-core pairs. Okay, big deal. Who cares about these data points? Well, if these CPUs were to perform identically, then we would expect the X values, the i7 scores, to be the same as the Y values, the Xeon scores. And all the points should fall on the line Y equals X. They are clearly not perfect. So what exactly is the best fit line that matches these points? Here it is, the best fit line. All right, it's not perfectly Y equals X, but the slope of that line is pretty close to the ideal value of 1. The square of the correlation coefficient is also right on 1, another sign of ideality. The y-intercept should be 0, but that number isn't too far off given the scale of our values. What does this all mean? It's just another way of showing that the i7s and Xeons have pretty much the same performance. Am I saying that the Nehalem i7s and Xeons are the same? No, but they sure seem to perform just about the same. Remember that Intel agrees that they should perform the same. They should only have two differences. One, the Xeons can handle more RAM, 32 gigabytes, and two, the Xeons can handle ECC RAM. I would love to test whether the i7s can handle 32 gigabytes of ECC RAM, but I can't because my only LGA 1156 motherboard accepts just 16 gigabytes of RAM. Furthermore, the motherboard can't support ECC RAM. Would I be surprised if the i7s can take more RAM with ECC support? Nope, I wouldn't be surprised one bit. I did poke around just a spec on the web, but I didn't find anyone that has addressed this question. Before I wrap up, I'm going to show some price performance information on these CPUs and see how they fit within the overall picture of the full Nehalem family. Here is a scatter plot with Cinebench R23 score performance on the y-axis and the bulk MSRP of the CPU, thank you Wikipedia, on the x-axis. I have single core scores on here, but all these CPUs have extremely similar single core scores. So there's not a lot of information in these blue dots. Let's focus on the orange dots for the multi-core scores. Keep in mind that these lower three CPUs are 4-core 4-thread CPUs. The others are 4-core 8-thread. What stands out to me is that going to the 4-core 8-thread X3440 gives a nice jump in performance, the y-axis, without much change in price, x-axis. From there, the other 4-core 8-thread CPUs just get more expensive, maybe a lot more expensive, without much performance gain. At launch, the X3440 was the bargain chip. That's great, but now let's focus on today's market prices. Here is the same performance information, but the x-axis is now the price I paid for these CPUs on eBay, including tax and shipping. Prices are in US dollars. Again, single core really isn't interesting. The multi-core prices are a bit more compressed than the previous graph, except for the tippy top chips, the i7-880 and the X3480. For what they deliver, these two are way overpriced. In contrast, the market doesn't really put a premium on the X3450 over the X3440. So I'd say that if you just happen to be in the market for a decade-old Intel CPU, then the X3450 might be your best pick. Of course, these prices will vary a bit based on each lot and each auction. These Nehalem i7s and Xeons show essentially the same performance in Cinebench. If you've watched all the way to the end, please consider subscribing, liking, or leaving a comment. Take care.